Okay, so passive house, it's becoming a permanent question on the construction studies exam. It's almost a banker at this stage. The first thing we're going to talk about with passive house is the importance of insulation, which is all what it's based about basically. We're going to talk about the air changes that need to take place in the house because it is so well insulated. And then we're also going to talk about optimizing the solar gain, the heat from solar gain, because in a passive house you don't have any fossil fuels to heat up radiators. You're depending completely on the heat from the sun and retaining that heat because of your super insulated house. So the first one, we're talking about the super insulation. We're going to focus on how they actually insulate it to passive house quality. So the basis of a passive house, if you were to sum it up in one kind of point, is that a passive house is a super insulated house. It has to pass quite stringent tests to actually be classified as passive house, and it has to be almost completely sealed. Okay. Now, if you were building a standard house, what you would notice is that you would have air vents in most of the external wall rooms. The reason for those is to allow a circulation of air, so you're ensuring that carbon dioxide levels don't get up to too much high of level and people suffocate in the house or whatever else. So in a passive house, when you're talking about it being almost completely sealed, you're not going to have those types of vents. So you have to have some way of getting the air changed. So that's going to be the second part. But to talk about the insulation first of all, what you're basically going to do is you're going to take your standard insulations and you're going to double them or triple them in almost every situation. So for example, if you had a studded wall and you're looking down the plan view of it, your studs would be set distance apart. You'd have your plasterboard or your cozy board on the inside of that, so that's the inside of the house. And normally what you would have a layer of insulation between those studs. Now in a passive house, you're just going to add more and more insulation on. So the walls are actually going to be thicker to accommodate that extra insulation. And these are the sorts of diagrams that are expected just to back up these points. So you're making note of the extra insulation. What you'll also have in the foundations is an extra insulation layer. Where you normally have your insulation, you'll just have 2 layers of it. But also what you'll have on the actual, if it's a cavity wall, around where the floor area would join on to the actual wall itself, instead of your normal concrete blocks, you'll have what's called these insulated blocks, just made from a special material. So they're going to be where the actual floor area is joining into your external wall. And you may have your cavity in between, and you can have normal blocks on the outside. But again, just highlight those. They're your insulated blocks. Now they will be more expensive, so you'd have to limit where you use them, but you use them in important areas where there's a junction going on between 2 different structures. Another area where you might have extra insulation is in the actual windows themselves. So on most passive houses you're going to have triple glazed windows rather than what would be your standard double glazed at the moment. That's a fairly easy enough sketch to draw. So what we'll draw is just the base of the window frame, and we'll have, instead of our double glazing, we put in 3 glazes of glass and obviously a gap in between them for the gas that actually retains heat. Again, label up triple glazing glass, and always try and just show where heat would be trying to escape and bounces back inwards. Okay, so in terms of insulation, just focus on areas like that, the walls, the floor, the windows, and emphasize the extra layers of insulation. The next thing I want to talk about is how the air changes take place. Now, this is a permanent fixture on the passive house question, and it's done through what's called your MVHR unit. Now, it's fairly easy to memorize what those letters are because it makes sense when you actually say it out loud. So what the unit is known as is a mechanical ventilation heat recovery unit. What the unit does is it acts like air conditioning, except instead of blowing cold air in, it retains the hot air in the house but recycles it as fresh air. Now we're going to go through a diagram to explain how it actually does that. If you were to look at a section of your typical passive house, let's say it's a 2-story passive house. So we put the walls, the floor, and we put a roof in. You might have your unit upstairs in the attic to keep it out of the way. Or if it was a bungalow house, you might have it towards the rear of the house just so it's not visible from the front. We'll have a division of rooms some way or another, so just divide it up. So I'm doing a 2-story in this case. Wouldn't particularly matter how many rooms you draw in. And we label up what we've drawn so far. So we have our MVHR unit. And we have our upstairs and our downstairs. Now the way this unit works is a series of pipes that go from one room to the next. The first pipe is going to take fresh air from outside. So it's bringing it inwards towards the house. It's going to pass it through this unit. And it's going to bring it down into the downstairs and whatever rooms are upstairs. So that's a flow of fresh air coming into the house. Now if it was just left like that, the air coming into the house would be whatever temperature is outside, so more than likely be quite cold. The way the unit works and the trick that they do is that at the same time you're going to have air being extracted outwards. So you have a different set of pipes, this time bringing the air outside. Again, these will pass through the unit and they'll be extracted from your rooms downstairs and your rooms upstairs. Put the arrowheads in, help to explain the direction the flow is going, and outside. Okay, so you have fresh air coming in, you have stale air going out. Now what's actually happening inside this unit, we're going to concentrate on it for a moment, is that there's a crisscross of the pipes. The air itself doesn't actually mix, but the heat or the energy of the two pipes are crossing over each other in numerous amounts of times. It works like your coil inside your hot water cylinder, constantly crossing over each other. And what's happening is there's a transfer of heat from one pipe to the other. So on the inside of that unit, now if you could draw this in coloured pens with blue and red, it would be a little bit easier to follow. But let's say for instance we have the fresh air coming inwards. That's going to cross over numerous times throughout the unit and then pass out into the upstairs and downstairs rooms. So that's the direction that the fresh air is coming in. At the same time, what I'm saying is the stale air is coming into the unit. It's been extracted out from the house and it's crossing over those pipes numerous times and then eventually travelling outside the house. But what's happening here is that the pipes are crossing over each other numerous times and the heat is transferring from one to the next. So when you have fresh air coming in that's outside temperature, by the time it actually leaves the unit, it's increased in temperature by a huge amount through that transfer of heat. So you have to be clear on that in your answer. There's no actual, the air itself doesn't mix, it's just the actual heat or the energy from one pipe to the next that is transferred. Now usually they will say, what they claim anyway, is that your heat retention can be up to 90%. Okay, and that's how you would have a constant supply of fresh air, because you don't have vents, you don't want to open windows, you want to just keep the same temperature as you can. It works both ways for a passive house. It's going to obviously keep the heat level up in the winter, but when it comes to summertime, this unit can just work in reverse and can act as air conditioning basically. So it'll cool down the house if need be. It's programmable, it's an electronic unit, so you can obviously set the different temperatures, how much heat you want to retain, what temperature you want it to be at, etc. So that's your MVHR unit. That's a permanent fixture on these passive house questions. The last thing I talked about in this question is about the solar gain that you need to have for a passive house. So the basic summary of a passive house is that it's an environmentally friendly house. You super insulate it at the beginning, at the construction stage, and that means that you have no fossil fuels systems to actually heat the house up. So in essence, you don't have an oil or a gas burn around the back of the house to turn on the radiators if you want. So you're dependent completely on the energy of the people in the house to actually create heat, so breathing in and breathing out. If you're cooking your dinner, if you have the oven on, you're depending on that heat being retained in the house. But your main supply of heat is going to come from your solar gain, the actual heat from the sun during the day. And you're hoping to retain that heat to a maximum amount and make sure it travels through the night and then the start the next day again. In order to do that, you would need to make sure that your house is actually orientated correctly. So the front of the house, which is going to be having the main living areas for during the day, should always be south facing. That's the kind of go-to default answer for this. It should always be south facing. So you're going to have your west and east directions obviously, and you're going to have your sun starting in one and setting at the other. So it's south facing at midday. Now that ensures that you're getting the maximum amount of sunlight possible towards the sides and fronts of the house throughout the day. What you also want to do with passive houses, you want to keep them as compact and as basic in shape as possible in order to actually be able to get the maximum amount of sunlight. On top of that, you want to have a large amount of glazing. So if you were to look at the layout of a passive house, ideally you want to have it as blocky and as square or rectangular as possible in terms of layout. What you want to avoid is bits of rooms sticking out or extensions or whatever else, and the reason is because you're creating blockages for sunlight if you have a layout like that. So you want to soak up as much heat as possible. Also, when you're talking about passive houses, ideally you try to keep them to one room deep or two at the most. And again, the reason for that is because of us draw a quick diagram of a section of the house, and we'll leave the front area for glazing. If you have the sunlight coming in, you're getting the maximum amount out of it if your house is actually quite shallow, if it's one room deep. So therefore you're gaining the most from the actual solar gain, and that means there's more heat in the house from that, which means there's more heat to retain. It means you can live at a more comfortable level in your passive house. The way a passive house would work in terms of keeping heat at night time is that you would have these insulated blocks, so they're down by the floor levels. You have a super insulated house in the walls and the floors, and what that's going to do is any heat that's soaked up during the day, it's going to retain that heat throughout the night and slowly release it. Now concrete blocks would do that anyway, but these insulated concrete blocks take it up a level. You probably would notice that if you come into the school, if the heating is on the whole week, the school only probably feels warm around Thursday or Friday, constantly. And that's because the blocks have soaked up the heat from Monday, Tuesday, Wednesday, and are now beginning to slowly release it. So that's kind of an example of how they take in heat and then release it.